we're given this diagram of a cuboid A, B, C, D, E, F, G, H, with AD equal to 24 centimeters, DC equal to 10 centimeters, and CG equal to 12 centimeters. The first thing we want to do is find the distance AG that goes from here up to here. If you want a good picture of AG, just look at the room you're sitting in. If you attach a piece of string to one bottom corner and stretch the string across the room diagonally to the opposite top corner, then that's AG. In order to work with AG, what we need to do is find a right-angled triangle that contains it. If we drop down GC and across the floor from A to C diagonally, then this triangle is right-angled just here. Let's draw the triangle ACG out. This is always a good idea when working with 3D problems. Any triangles you want to look at more closely, draw them on a separate diagram. We're right-angled here at C. So this is ACG. If you look back at your room and imagine your piece of string stretched across, GC would be the line where two walls meet, and clearly this line meets the floor at right angles. This length we know is 12 centimeters, but we actually don't know any other information in this triangle, so at the moment we can't proceed to find AG. How are we going to do this? We can work out the length of AC by finding another triangle in which AC is a side. If we draw this triangle out separately, this is the triangle ADC. It's right-angled here at the corner of the room, so that's ADC. We know that AD is 24 centimeters long, and that CD is 10 centimeters long. We can now work out AC using Pythagoras' theorem. Let's call AC x. We can then use this value here in this diagram. So, to find x, we need to use Pythagoras' theorem. By Pythagoras' theorem, the hypotenuse squared is equal to the two shorter sides squared and added together. Calculating, this gives us that x squared is equal to 676. There's actually no need for us to find the value of x. It wasn't a requirement of the question, and as you'll see, we're just going to use the value of x squared anyway, so we don't need to work out x. So x is AC. AG I'm going to call y. Using Pythagoras' theorem, y squared is equal to x squared plus 12 squared. Note, this is why we didn't need to actually find the value of x. We were going to use x squared anyway. So y squared is going to be x squared, which we know is 676, plus 12 squared. So calculating, y squared is equal to 820 y then is going to be the square root of 820, which is 28.6356 and so on. So y is 28.6 centimeters, correct to 3 significant figures. When doing 3D problems, very often we need to use values we've worked out again. The value I've just pointed to here, before we rounded to 3 significant figures, we should keep a note of, maybe to 5 significant figures, in case we need to use it in subsequent calculations. If we use a value we've already rounded to 3 significant figures, in order to give another answer to 3 significant figures, we may build in an inaccuracy into our answer. As it happens, in this particular example, we don't need to use the value of y again. In part B, we're asked to find the size of the angle FCB. In order to do this, we need to draw the triangle FCB. We can see this in the diagram here, FC to B and the side FB. Just look at the wall of your room. Clearly FBC is a right angle. Let's follow through with our policy of always drawing out separately triangles we want to work with. We know the right angle is just here. This is F, C and B. Looking at the diagram, we can see BC is 24 centimeters. FB will be 12 centimeters. We want to work out FCB, which is this angle here, and I'm going to call it X. This side clearly is the hypotenuse. This is the adjacent to the angle marked X, and this is the opposite. We know the adjacent and the opposite. Writing down our mnemonic, so, car and toa, in a situation where we have O and A, we know it's toa. Working from the definition, the tangent of the angle, which I've called X, is equal to the opposite, which is 12, divided by the adjacent, which is 24. So X is going to be the inverse tangent of 12 divided by 24. So to calculate, we do shift tan of 12 divided by 24, which gives us 26.565 and so on, or 26.6 degrees, correct to 3 significant figures.